Hi everyone, my name is Tom. Thank you for joining. Speaking on behalf of the entire Dataflow Streaming team, and also shout out to my teammate Ryan who helped me put this together. He could not attend the summit, but he helped a lot with this. We'll talk about a few different topics of what's coming next in Dataflow Streaming. First is fast job updates. How can you update your job with less downtime? Second, direct path. We're making some improvements to the Dataflow architecture to eliminate bottlenecks. Kafka integration. Kafka has become an important source and sink in Dataflow Streaming recently, and we want to make that the best experience possible for our customers. High key cardinality. We continue to make optimizations to support more workloads, especially with lots of keys. And ML-aware streaming to support more and more Dataflow streaming workloads. And lastly, observability to make sure customers can understand what's happening in their pipeline and open less support tickets. So first, fast job updates. Traditionally, if you want to update your Dataflow job, you can perform an in-flight update, which is only modifying the total number of workers, the min and max workers, or some auto-scaling parameters like the target CPU utilization. Otherwise, you can launch a replacement job with the update option. This is typically slow for some customers where they would like things to be quicker. In this workflow, we wait for the existing VMs to shut down and bring up new VMs for the new job before any processing continues. And so we want to reduce that downtime. If you want to work around that, currently you could just stop and replace your job without waiting for the update between continuous jobs, or run parallel pipelines, which was kind of a manual hacky thing customers did. So with, like I said, this is kind of slow, 5, 10, or 15 minutes for some customers. So we want to reduce that downtime. With the new version of Fast Job Update, you can now swap out your original pipeline in parallel. This is useful if you don't care about a small number of duplicates or partial aggregations. So again, that eliminates the pause in processing and reduces your toil in managing multiple pipelines at the same time. So in this feature, the key changes are starting parallel worker pools and initializing to the same number of workers. This was another pain point with the traditional update, where we would just start with the initial number of workers as the old job. So now we can start at the same number of workers the old job was currently running with at the end. Just to help visualize this, a ridge is running in the light blue, and it started and running. You may have some pipeline updates, so you want to start a new job, and start those workers in parallel to the old running job. Once the original job is done draining, the next job can, once the workers are up, the original job can start draining, and the new job can start processing. Here's just another visualization of both jobs overlapping in the processing while the one job is draining, and just showing the two different job IDs. And how you would use this, you can specify the job you're replacing and then specify how long you want them to run in parallel. And yeah, this is coming soon, but not quite ready. We plan to continue adding improvements to this new feature. So you can keep the same job name instead of having to specify a new job name. Doing a stop and replace flow where there's no overlap in processing to reduce anything like concerns with duplicates, and also reduce the downtime for the original update compatible job. Next is direct path. As I mentioned before, due to some limitations, the original Dataflow Streaming design included this dispatcher that was in between user worker and backend worker communication. This is just for historical reasons. We couldn't expose addresses for the backend directly to customer VMs. So with some newer cloud technology in GCP, we can take advantage of that to make the architecture a bit better. Instead of needing to plumb all of your output between stages through dispatchers and then through to the backend, user workers can just talk to the dispatchers to get information about the backend workers. So yeah, there's one less hop in sending data to the backend, and the dispatcher was also kind of a shared component across jobs. So if it was suddenly overwhelmed by another customer job, it could affect, like from customer A's job, it could affect customer B's job. So this helps eliminate some of those issues too. Yep, so this simplifies the architecture, reduces noisy neighbor, what I just described, and improves latency on the data path. Doing some testing, we tested this on many jobs, but as a simple example, or a common example, Kafka to BigQuery. This reduced the backlog and the data watermark lag. So this looked really good on all of our test jobs. Third is Kafka integration. Like I said, Kafka is an important source in streaming data flow lately. And if you attended some other talks today, you might have seen managed I/O. This is supported with Kafka and simplifies how you specify I/O connectors. And then Dataflow also provides a service for you to upgrade those transforms without having to upgrade your Beam version for your entire pipeline. So, yep, Dataflow automatically upgrades the I/O, and then it's a simple API. This is just a very simplified diagram of how it works in Dataflow. As you can see, you submit your job to Dataflow service, and then when executing the job, the VMs will also will use the upgraded version of your I/O, which might be version Y, and the rest of your pipeline can use the Beam version you launched with, which may be version X. So yeah, this is really simple. As an example with Kafka, you just specify read or write with the KafkaIO, and then whatever configuration you need to do. So you don't have to do things specific to each transform. It's just one config for each I/O. As an example, more specific example for Kafka, just specifying the bootstrap server's topic and max read time for that source. We read from Kafka with that simple config. Another issue with Kafka is limited parallelism due to the partitions. In converting your Kafka source to the job graph, Beam and Dataflow convert the partitions to keys. Sometimes you might have fused processing with the Kafka read step that might be slow, and instead you may want to redistribute, say 10 partitions to 100 keys or something like that. So you can add parallelism with the redistribute transform, and that's built into the Kafka read I/O now as well. Redistribute is really simple. It's just adding a key, shuffling, and then removing that key when you do your downstream processing. For at least once, you can allow duplicates. This makes it cheaper to shuffle data because we don't have to persist as much in the back end. So you can see how adding redistribute helped you achieve higher throughput, but at more cost. And using the allow duplicates mode, if that's okay for your needs, can bring the cost back down to similar to what it was before, but still with the higher throughput. And offset deduplication is another optimization we're making where we want to keep the shuffle part of your redistribute cheap, but allow you to use this in exactly once mode. So this is not quite ready yet, but coming soon to Beam, where you can add parallelism to your Kafka source without switching to at least once mode for that cost optimization. Okay, high key cardinality. In the past, a lot of Dataflow pipelines run with a few thousand keys, and it works pretty well. Lately, there are a lot of Dataflow pipelines with millions and millions of keys, and that wasn't well tested in the past and found some new bottlenecks in Dataflow. So with customers having more use cases like this, we're working on adding better support to Beam and Dataflow. There's a lot of small optimizations that have just been implemented in versions 2.63 and later to help with this. To test that out, this is a Kafka job. And you can see the Beam 263 with those improvements. Process 60% higher throughput. Doing some additional testing, Nextmark queries are one way to benchmark streaming jobs, and we saw a 15% runtime reduction with those as well. Okay, now with AI and ML becoming super popular, those workloads didn't always work super well in Dataflow streaming by default. So we're adding some more support to Beam and Dataflow to help with that. First is auto-scaling. In classic streaming workloads, work was finished within a second or a few seconds and worked really well with how auto-scaling worked by default. With ML workloads where some things take a few minutes, there are lots of rework and retries due to auto-scaling that were really expensive. This is an example job. The job is scaling up and down between different workers and retrying lots of work on the bottom, building up backlog. So one thing we're doing is adding async do functions. This helps the backend know, helps the backend optimize this type of work where there's long processing. There's extra RPCs made to the Dataflow backend, so it's not best when you have the classic fast processing. But with ML, this works really well. And with this auto-scaling and async do fun support, we were able to make ML pipelines work a lot better. So you can see 650 input messages has around 250 retries. With this auto-scaling and retry optimization, there was only one retry at some point when there was an auto-scaling event. And just looking at the performance benchmark, this reduced the backlog and number of workers required to process this ML workload by a lot. So in Beam, if you have those long-running do funds, all you need to do is wrap it using that async wrapper on the second line. And that lets the Beam and Dataflow runner know to do that extra optimization for long-running do funds. And then with the parallelism annotation, that helps limit the amount of queued work sent to user workers, so there's less retries. But yeah, this is all coming out in the next Beam release, so it's not quite ready. And finally, with ML-aware streaming is write fitting. Before, this was only supported in batch. So with streaming, you can now add resource hints for the minimum RAM and the accelerator. So you can use GPU for your ML workloads. Okay, last but not least is observability. This is an area that I care about a lot, and I always want to keep improving for customers. So I hope these will be useful for you, and if you have more pain points, I would be happy to hear about them. One new improvement is metrics. We're always adding new metrics for customers to figure out what's wrong with their pipeline. Before these new metrics, a lot of the observability was around which stage was slow. With the do fund latency metrics, you can now see what part of the stage was slow. Things like the average latency, max min, oldest active message. Those can help you dive into why that stage was slow. So if you're debugging why a stage was slow, you could look at these in Metric Explorer and identify the time you want to look at and see which stage was slow there. Same with the average. You can see on average what's taking slow to process. Bottleneck detection. There's a lot of different parts of streaming pipelines. The do funds, shuffles, checkpointing state. And this is all connected. And sometimes it's hard to tell when your pipeline is falling behind what's the root cause of this, because all the queues are filling up. I don't know what's causing that issue. Usually there's one bottleneck that is slow, and then everything upstream of that starts queuing as well. So we want to give the customers better ways to identify this and eliminate guessing and trying things without being sure of what's wrong. Just a quick example, maybe writing to PubSub or BigQuery is bottlenecked just by quota. You would want to see in your Dataflow UI which step is slow. So there's new metrics shown in the steps with the data lag and the total wall time and how many stages this is spread across. And in the side panel, we're showing more things like the max operation latency and if there are bottlenecked keys, and even providing some resources to help you troubleshoot that. These are just more examples of bottleneck detection, finding one stuck key. And we keep iterating on this and adding more things like key parallelism. Another common case of stuckness is having so many keys where the max number of workers can't even process all of the keys. So we're trying to pinpoint different types of parallelism and other bottlenecks in the pipeline. And advanced debugging. Sometimes you want to know what code is slow in your pipeline. Traditionally, we will log stack traces if something's stuck for more than 5 minutes. That's now with customers trying to run things faster and faster, that's not always sufficient. So we want to provide stack traces to help customers identify these bottlenecks on their own. So we're looking to add new debugging tabs. And you can search the debug tabs for different workers that are handling your workload and see what stacks are running to help you find out what code was stuck or slow. And that's all I have. Thank you.